So this exercise is related to electrical circuits. First 8 page we have discussed, so I will start with page 9. In page 9, first we have to state Ohm's law. What is the statement of the Ohm's law? So according to Ohm's law, voltage is directly proportional to current for a constant resistance. So Ohm's law simply state that the current through a conductor is directly proportional to the voltage across the conductor, and when we are keeping the temperature constant, at a constant temperature, voltage is directly proportional to current through a conductor. That is a statement of the Ohm's law. The next is the variation of a current with a potential V across a filament is shown. Figure 5.1 shows a voltage and a current graph. Whenever we have a IV graph is there, we have current on y-axis and voltage on x-axis. What the slope represent? The slope represent the quantity on y-axis divided by quantity on x-axis. So on y-axis, we have current, and on x-axis we have voltage. So in that case, what the slope represent? Because we have the formula V equals IR. So I will be equals to V over R, or R will be equals to V over I. So the resistance is the ratio between voltage and current, but the slope is representing I over V. So what it shows? It shows that the slope is representing 1 over R. So as you can see, the slope is decreasing for this. So if a slope is decreasing, what happened to the resistance? The resistance of a conductor will increase, or resistance of this electrical component is increasing. So in part B, the resistance of a filament lamp increases with the potential. State how figure 5.1 shows this. So how figure 5.1 shows that, because resistance is a ratio between voltage and current, the ratio of a voltage and current is representing resistance. So as the ratio of voltage and current is increasing, because if the slope is decreasing, as the slope is decreasing, resistance is increasing, and resistance is actually a ratio between voltage and current. So the ratio between voltage and current is increasing. That shows that the resistance of this conductor or a material is also increasing. The next is explain why the resistance varies in this way. What is the reason why for a filament lamp or a bulb, resistance is increasing as so basically what happened as we increase the potential, it's a one mark. We don't have to explain the internal factor which is causing this change. But what actually happened, what will happen when we increase the potential, the current is increasing. So as a result, when the current is increasing, there are more collisions between the electrons which are moving and the lattice. When there are more electrons, like there are more collision, when there are more collisions here, as a result, what will happen? The temperature of the material is also increasing because the electrons are moving through the structure. When these electrons are moving through a structure, voltage and current are directly proportional. As we apply more potential, more current is there. More current means like more charges in per second. So there are more collision between the lattice of the positive ion and the moving electrons. As a result of greater number of the collision between them, the lattice vibration increases. As the lattice vibration increase, the resistance will also increase. So you just have to relate here, but because it's of only one mark, that's why you can simply mention the temperature is increasing. But I was explaining why the temperature is increasing. So the same question can be of 3 marks. The same question is of 1 mark. Because here it's of 1 mark, so we just mention the temperature increase. But if it was a 3 marks, then we'll explain why the temperature is increasing. So how you'll relate that, you will mention increase in potential increases the current, which increases the number of the collision between the lattice of the positive ion and the moving electrons. As a result, the lattice vibration increases, the temperature of a material increase, so its resistance is also increasing. And whenever you write the answer, you try to relate sentences with each other. Like the first sentence should be related, the second sentence which you mentioned should be related to the first sentence. So it should be continuation. You cannot say voltage increase, temperature directly increases, like for a 3 mark question. It should be explained. The next is a potential divider circuit. A circuit will divide the potential. So if the movable part is exactly at the center or a midway between A and B, so if it's a 12-volt supply, 6 volts will be here and 6 volts will be here, because this is a potential divider circuit will divide the voltage. So as a result, we'll have same volts across, because according to the Kirchhoff's second law, the total EMF will be equal to total potential difference in a loop. So this is one loop. This total is 12. This is a second loop. The total will also be 12. So figure 5.2 shows a circuit with a battery. No, I'm just explaining an idea. Let's say it was in the center. But now, according to a question, we'll solve. So EMF is a 12 volts connected, a linear potentiometer. A, B, and two identical lamps are there, P and Q. The battery has a negligible internal resistance, because if the battery is having an internal resistance, so the terminal voltage or a terminal potential difference cannot be 12, it will be less than 12 if it is allowing the current to flow. The lamps each have same IV characteristic as shown in figure 5.1, the graph. When a slider of a potentiometer is at the midpoint, so they mention it's at the midpoint, as shown in a figure 5.2, the current in the battery is 1.78. Determine the current in lamp P. So what we have to do, we have to use, this is they already mentioned it is at midpoint. So if it is at midpoint, what voltage will be here? 6, and what voltage will be here? 6. So what is the voltage across the lamp? The voltage across the lamp will also be 6, because they are connected in parallel to the section of this potentiometer. It receives the same voltage. Now, what we have to do, when the voltage across the lamp is 6 volts, we'll find what should be the current using a graph. So by drawing a line, when the potential is 6, you draw a line. Whenever you're using a graph in your answer, you always show, like, draw these. So the current is 1.5. The question is, what is the current? Because this value is there when it is 6, 1.5, 10 boxes equals to 0.5, so each is 0.05. So this will be 1.55 ampere. So it means the current of a 1.55 ampere, the current of 1.55 ampere will be here, passing through P, and already they mentioned 1.78 ampere enter the circuit. This was 1.78. So 1.78 ampere enter, some of the current will flow through this branch, and the remaining current will flow through the second branch. Both lamps have the same potential across them, so the same voltage will flow, same current, I mean, will flow through them. So 1.55 ampere. So we just have to use the graph. So when the voltage is 6, what is the current in lamp P? It's a 1 mark, so directly you don't need to show the working. Directly you can write 1.55 amperes. The next is total power dissipated in lamps P and Q. So we need the total power which is dissipated across by these lamps. So we can first find the power dissipated in each lamp, and then you can just multiply that by 2 because they have the same potential. So same power dissipation, identical lamps are there. So I can use a formula P is equals to I square R, P is equals to VI. But as we know, the current and the voltage, as the voltage was 6 volts here and the current is 1.55. Same thing, the voltage is 6 and the current is also 1.55. So I'll find the power here, P is equals to VI. And they have the identical voltage, and then I'll simply multiply that by 2. So 6 into 1.55, that will give 9.3 for each, okay? And then 9.3 multiply by 2, so 18.6 for both. Because we need for both, so that's why we multiply this by 2. So the total power dissipated in each is 9.3. We multiply by 2, we got 18.6. And the unit of the power is what? The resistance of a potentiometer between A and B. So how we can work out the resistance of a potentiometer? So we should know what current is flowing through. The voltage across the potential, total voltage across the potentiometer from A to B is 12. This section of a potentiometer is 6. This section is also 6. But the total potential or total voltage is 12. What is the total current from the supply? The 1.78 ampere, the current enter, and out of 1.78, they mention the current which, like we calculated, 1.55 ampere flow here. So what is the remaining current? We just subtract that. So 1.78 minus 1.55. So 0.23 ampere. So 0.23 ampere is a current which will flow through the potentiometer, and the potential or a voltage across the potentiometer is 12. We need the resistance of this component. Resistance is a ratio between voltage and a current. The voltage is 12 and the current is 0.23 ampere. So 12 divided by 0.23, we get the resistance, which is 52, and the unit of the resistance is ohm. 52.2 ohm. The next we have the slider of a potentiometer in C is moved to end A. State and explain the effect on the brightness of the lamps P and Q. So this is a sliding contact. The sliding contact is moved. The sliding contact is moved to position A. So what will happen? Because this part will not have any resistance to the potential here, the potential difference will be 0, and the potential difference in this part will be 12. So the potential across the lamp P will be 0 and the potential across lamp Q will be 12. So the lamp P, it does not have any potential, so the lamp P will be off. But what happened to lamp Q? Because it has more potential, so its brightness will increase. Because when you work out the power, you'll find it will have a high power. So its brightness will also increase. Increasing a voltage across the lamp will increase its power output or the brightness, you can also say. Is it clear discussion? Anyone having a doubt in this part? Last part was of 2 marks. So 1 mark is for mentioning that as we move the sliding contact to position A, the brightness, the lamp P will go off because it is having no potential across it, so the potential is 0, potential difference, where lamp Q will have a greater brightness or its brightness will increase as more potential is across lamp 2. Lamp Q, I mean. Next is state Kirchhoff's first law. What is the statement of the Kirchhoff's first law? The Kirchhoff first law states that at any point of the electrical circuit, the current total current enter the circuit is always equals to current leave the circuit. So how much current will enter at any point of a circuit, the same amount of the current will leave the circuit. That's the Kirchhoff first law. So if we have I1, I2, and I3, so according to Kirchhoff's first law, I1 is equals to I2 plus I3. And Kirchhoff's second law is about the potential. Like in a loop, the total EMF will be equals to total potential difference. A battery is connected to two resistors X and Y as shown. The resistor X is greater, like the resistance of resistor X is greater than Y. State and explain which resistor dissipate more power. This is a repeated question. Sometime instead of resistor, they can also give you the lamps and they can ask, compare the brightness of these lamps. So first thing, whenever components are connected in parallel, they will have the same potential difference. Like if I say the potential here is V, same potential will be there across X and same potential will be there across Y. Now, they already mentioned that the resistance of X is greater than the resistance of Y. So when the current will flow, current always flow through the least resistive path. So if the total current was I, that will divide it into I1 and I2. And we have the formula for power. We can use any formula like P is equals to. You can use a formula P is equals to VI or P is equals to I square R or P is equals to V square over R. Like, let's say I use a formula P is equals to VI because here voltage is in the question, as you can see, the voltage is, they are connected in parallel, so voltage is constant. So for a constant voltage, what is the relation between the current and the power? Current and power are directly proportional. So means one which is having a large current will have more power dissipated. So which one will have a greater power dissipation? So the power of Y will be more than power of X. If I use this formula, let's say another student used a formula to explain the power and he used or she used P is equals to V square over R. So here the voltage is constant. If the voltage is constant, so what is the relation between the power and the resistance? So if in this case it's inversely proportional, so the one which will have a least resistance will have more power. Again, we'll get the Y as the right answer. And the third formula, P is equals to I square R. This formula Y directly we cannot use like P is equals to I square R because it depends on the current square and the resistance, the product. And in the question, the resistance has changed and the current is also changing. That's why P is equals to I square R. We are not using it because we don't know what is the resistance and what is how much current, a specific number or the value of the current which flow. That's why it is this formula is having three unknown variables, so it will be difficult to establish a relation between them. So whenever you have an equation, you always try to when you want to relate the two quantities, so you'll try to figure it out that which one is a constant factor and then you compare the other two. So why P equals I square R is not suitable to explain the idea here as we don't know how much current is there and what is the resistance, the specific number. Is it clear? The power dissipation. So when you relate, you will mention they will have the same potential. The one which is having a high resistance will have less power, or the one which is having low resistance will have more power dissipated. So Y will have greater power than X. So when two are connected in parallel, that is a relation. The one which is a low resistance will have more power. But what if the same question was there and now you have two resistors X and Y are connected in series. So when two components are connected in series, the factor which is constant is a current. So I is constant here. And in the question, we mentioned that the resistance of X is greater than the resistance of Y. Now I want to compare which one have a greater power dissipation. So if I use a formula P is equals to VI. Because they have this, they are connected in series, so they will have the same current, but the one in series, the one which is having more resistance, will have more potential across it. So if the current is constant, the same, the one with the more voltage will have more power dissipated. So in that case, if they're connected in series, X will be the answer. Or I can also use this formula, P is equals to I square R. Current is same in both. So the one which is having a high resistance will have more power. So again, I will get X. But I cannot use this formula that P is equals to V square over R. Why I cannot use this one? As I don't know what is the potential, like the value of the potential difference as well as the specific resistance. So when two components connected in series, the one with a high resistance will have more power. But when two components are connected in parallel, the one with a low resistance will have more power. Is it clear? This part? Any doubt in this? The next is two resistors are made up of a wire that have the same length. Both wires are made from same metal and of same resistivity. State and explain which resistor is made up of a wire large cross-sectional area. Whenever two wires are made up of same material, the formula which relate the length, resistance and area, that is R, the resistance is equals to rho, the resistivity, length divided by area. So because if the two wires are made up of same material, they will have same resistivity. So I can say R A over L will be equals to rho. So simply I can say R1 A1 over L1 is equals to R2 A2 over L2. In the question, they mentioned they are made up of same length. So if they have the same length, L lengths will cancel out because it's the same variable, same number. So the product of R1 A1 will be equals to product of R2 A2. If we call this as a X and this we call as a Y, so this is a resistance of X, area of X. This is a resistance of Y and the area of Y. In the question, they mention that the resistance of X is greater and the resistance of Y is less. So if the resistance of X, because we want the same product, like the product of the resistance and area should be same for both. So if the one is having a high resistance, it means will be thinner wire. But the one which is having a low resistance, it will be a thicker wire with the same length of same length. So state and explain which resistor is made up of a wire with a large cross-sectional area. So which wire is having a greater cross-sectional area or the large cross-sectional area? So Y is having a larger cross-sectional area. Now, how to write the structure answer? Yes, how to write a structure answer? In a structure answer, in physics, you can also include the equations. So first, when you include this equation, you will say rho is equals to RA over L. That should be constant. So R1 A1 over L1 should be equals to R2 A2 over L2. Or we can say the product of the resistance and the cross-sectional area of wire X should be equals to the product of the resistance and cross-sectional area of wire Y. So the wire Y should have a large area because it has low resistance to have the same product. So state and explain which wire is made up of large cross-sectional area. We'll say Y, and the reason is that because the ratio of the product of even because Y is having a smaller, in the question, Y is having a smaller resistance. So if the two wires are made up of same length, same material, so it should be a it should have a large area which reduces the resistance. As the length is same and they are made up of same material. Next is a potential divider circuit. A battery of EMF electromotive force of a 9 volt with a negligible internal resistance is connected in series with a LDR light dependent resistor. LDR is used in a light sensitive circuits, light sensing circuits. When it is too bright, what happened to resistance of LDR? It decreases. When it is dark, what happened to resistance of LDR? It increases. So the resistance of LDR changes with intensity of the light. So when it is bright, it will have low resistance, so it will have less potential. In comparison, more potential across the other one. But if it is dark, it will have a high resistance, so more potential. In comparison, less potential across the other component. A voltmeter is connected across a fixed resistor. The resistance of a voltmeter is 5.4 volts. Calculate the current in the circuit. So the reading here is 5.4. So same potential will be there. So we'll have a potential difference of 5.4. We just need a current. We have the resistance. So V equals IR. The current will be the ratio between the voltage and the resistance. So voltage is 9 and the resistance is 1800. 9 divided by 1800. Sorry, the potential is 5.4, not 9, because 9 was the total. We need the current here across this one, and that will be the same current flow through the circuit. So 5.4 divided by 1800. What's the answer for this? 3 exponent 8, okay. 3 exponent minus 3, okay. So 3 milliamperes. The next is calculate the resistance of LDR. How to know the resistance of LDR? Already in the question, they mentioned 5.4 volts here. So how much voltage is across the other component? So we just subtract. So 9 minus 5.4 will be the voltage across this one. So that is 3.6. And they will have the same current as they're connected in series. So if the current which flow through the first one was 3 milliampere, the current flow through the second component is also 3 milliampere. So resistance is a ratio between voltage and a current. Voltage is 3.6 and the current is 3 milliampere. So it's 1200 ohm. And the ratio of the resistance and the ratio of voltage should always be same. The intensity of illuminating the intensity of a light illuminating the LDR increases by reference to the circuit. If this voltmeter was attached up with the battery, will it check the voltage across the resistor L or LDR or EMF of the battery? If this voltmeter was connected here, it will show the terminal voltage. Like if we ignore the internal resistance, then the voltmeter reading will be 9. If we ignore the internal resistance. But if there was a battery with an internal resistance and there was a voltmeter connected here, then the voltmeter reading, it's labeled 9, the EMF, but it won't read 9, it will read less than 9. Because when the current is passing through a circuit, some of the potential or the voltage loss internally. If one point on the top and the second connection of voltmeter at the bottom. You mean like this? If a voltmeter connected like this, then that will also read the potential across. In that case also it's the same thing. It will record the potential across this. If the voltage here It's also like a parallel combination, but so in that case, it will record the potential across this part. Like in the question, it is 5.4 volts here, so this will also read 5.4. If I connect a voltmeter like this, it will read 3.6. If I connect a voltmeter like this, it will read 9. If battery with no internal resistance. But when two branches are there, your question is actually related to potentiometer, in which we have two branches in the circuit. And we have, let's say, we have two branches with two different resistors connected to the same supply. Let's say it's a 10-volt supply. And this is one loop. This is one loop of a circuit. This is a second loop of the circuit. The total in each loop should be, let's say this is 3 volt, this is 7 volts. This one is example 5 volt, or let's make it 4 and 6, or 6 volts here, 4 volts here, and 6 volts will be here. Now, it depends if I connect a voltmeter, because the charges, when they enter the circuit, they have like 10 joules of energy. When it passes through this component, it transfers 3, so remaining is 7 joules. And when it passes through this component, it will have 0 joule to transfer. It will have energy to move, but no energy to transfer. Voltage is not same in series. Voltage divided in series, and it is same in parallel. These are connected in parallel to the battery. These are two different branches. So different branches can have different voltage across them. If we were having, so when the charges enter, it will have 10 joules here. It transfer 4, so remaining will be 6. And it transfers 6, remaining will be 0. So if I connect a voltmeter here between these 2 points, because voltmeter record the difference in the energy of the 2 points. So if I connect a voltmeter here, what will the reading on the voltmeter? It will be 0, because there is no potential difference. If I connect a voltmeter here, what it will read? Because here is 6 and here is 10. So a voltmeter read 4. If I connect a voltmeter here, here is 6 and here is 7. So what is the reading on the voltmeter? 1. Because voltmeter record the potential difference. So this is when two branches are there in series, the voltage divide and the current is same. But in a potentiometer, like a potential divider circuit, when we use a variable resistor as a potentiometer, in that case, what happened? Like you have a variable resistor and you connected two resistors. Or you connected two lamps. Because in that part it is connected. So if it's a 10 volt supply and we have 3 volts here and 7 volts here, because this part of a circuit is connected, so same 3 volt will be here, same 7 volts will be here. Because there's a connection between the branches as well. In this circuit, the two branches are separately connected. Like this is one way for the charges to flow in one branch. This is another way for the charges to flow in second branch. But here what happened when the charges are moving, they can flow like this, they can flow like this, and they can flow like this as well. So that's why when variable resistor is used as a potentiometer, it divides the voltage evenly. What is the voltage between the sections of the potential variable resistor? Same voltage will be there across the component. But when branches are there, two separate branches, the voltage in total voltage or a potential difference in each branch will be same, but the potential across each component will not be same. It may be same or may not be same. Is it clear? So the intensity of a light illuminating the LDR increases by reference to the current in the circuit. State and explain the change, if any, on the voltmeter reading. So if we change the light intensity, if we have more light, so what happened to resistance of LDR? The resistance of LDR decreases. If the resistance of LDR decreases, so they are connected in series, so less voltage or a potential across LDR, and there will be more voltage or a potential across the fixed resistor. Because in a potential divider circuits or series circuit, the total voltage will be constant if one component is having a high voltage or more potential across one of the component, the other component will have less voltage. So you just have to compare the readings. So LDR resistance will decrease. So current in the circuit will increase. As the current in the circuit will increase, there will be more voltage or a potential across the fixed resistor and less voltage across, because this is a series circuit. So in a series circuit, the voltage will always divide. If I say it's a 9 volt, if 2 volts here, 7 volts will be here. But if it is 3 volts, this will have 6 volts. If this was 4 volts, this will be 5 volts. If this is 5 volts, this will be 4 volts. So in a series circuit, the potential divide between the component. So if one component is having a high resistance, it will have more potential, and the other component will have less resistance. So it will have low voltage across it. Is it clear? Discussion? Any doubt in this?